Hello, today we're going to look at some more quadratic word problems, but instead of using quadratic formula and finding, for instance, how long it takes for something to hit the ground, today we're going to be doing word problems that involve the maximum or minimum of a quadratic function. So if you think back to when we did our quadratic graphing stuff last semester, when you graph a quadratic, which we're not going to actually graph today, we're just going to be finding things that would be on the graph. It either looks like this, a regular parabola, or like this, an upside down parabola. If it's a regular facing upward parabola, our graph has a minimum, which is the lowest point. If it is an upside down parabola, our graph has a maximum, which is the highest point on the graph. The minimum or maximum value is the y-coordinate of the vertex. And then we'll also be concerned with the x-coordinate of the vertex because that tells us at what time or how long it takes for something to the minimum or maximum to happen. So also thinking back to when we graph quadratics, in order to find the vertex when we're in standard form, we start by finding the x-coordinate using this formula right here, x equals negative b over 2a. That'll give us one of the two answers to each of our questions. And then we take that x value and sub it into our equation to find the y-coordinate of our vertex, which will give us either the minimum or maximum value. For a lot of these, you're going to see t instead of x, especially if you're dealing with time. And you might see something like h of t instead of y. That's just function notation instead of y equals notation. I also have Desmos pulled up here so that way we can use it for our calculations, especially when we get into some bigger numbers trying to find the minimum or maximum values. Let's go ahead and dive right in. You are trying to dunk a basketball. The height your feet are above the ground is given by the function h of t equals negative 16t squared plus 18t. So basically what happens if this is the floor, which your gym floor would be hopefully much more even than that, your feet start here, you jump up, eventually hit some sort of max height, and then hit the ground again. The x-axis here would represent time, and the y-axis would be your height. So we want us to answer two things here. What is the maximum height your feet will be above the ground? That maximum height is going to be the y-coordinate of your vertex. We can't find that until we know what the x-coordinate is. The second question, which is actually what we're going to deal with first, at what time t, which is the same as x here, since it's the variable in our equation, at what time t will you achieve your maximum height? So to find that time t, we're going to start with that formula for the axis of symmetry. We can say t instead of x equals negative b over 2a. b is the number in front of regular t here, so negative b is going to be negative 18 over 2 times a is the number in front of t squared, so negative 16. Simplifying that out, we get negative 18 over 2 times 16 is negative 32. And let's do that as a decimal because we wouldn't normally say negative 18 over negative 32 seconds. I'm just going to do that in Desmos. Negative 18 divided by negative 32 gives us, we're going to go ahead and round to two decimal places, 0.56 seconds. So whenever they're asking for the time or at what value do you reach the min or max, you're finding the x-coordinate, you do negative b over 2a. Now that we know that x-coordinate, we can plug it, or t in this case, we can plug it in for our variable in our equation to find the y value, which is our maximum height. So let's do that. So to find that maximum height, instead of t, we're going to put 0.56. So h of 0.56 is replace those t's 0.56. So negative 16 times 0.56 squared plus 18 times 0.56. Once again, let's use Desmos for that. Type in exactly. Helps if I do the same thing. Type in exactly what you see there. Parentheses where you need to. And once again, we'll round that to 2 decimal places. And so then our answer here, we'll go ahead and round to 2 decimal places, will be 5.06 feet. So all we did there was take 0.56 and sub it in for our t's there. All right, let's do one more. This time, instead of time, we're dealing with profit in terms of units sold X. The profit a company makes in thousands of dollars P of X is given in terms of units sold X by the equation right here. Since the first question is asking how many units must be sold to maximize profits, units is X here, so we're going to use that X equals negative B over 2A to answer this part. So subbing in the B and A from the equation, B is the number in front of X, so negative B is going to be negative 460 over 2 times A, and this problem is negative 2. And we could actually type all of that into Desmos at once if we would like. Negative 460 over 2 times negative 2, and we get 115. 115 what? It's asking for 115 units of product. So 115 units is our answer here. Next, I must find the maximum profit. And so that's P of X, which means we're going to take that 115 and plug it in for all the X's. So P of 115 is going to be negative 2 times 115 squared plus 460 times 115 minus 26,210. Once again, let's use Desmos for the heavy lifting because that would be a lot to try to do in your head all at once. I wouldn't really want to do 115 squared in my head if I didn't have to. And we get 240. This one's kind of tricky unit-wise, so let's take a look back at our problem. It is not just 240, it's $240,000. So your best answer here would be $240,000. Sometimes you see this in like newspaper articles and stuff too. Instead of writing out the expanded like this 240,000, they do 240 in numbers and then the word thousand as a word. Either way is fine with me. That is it for today for some quick max and min word problems of quadratics. Have a wonderful day.